All right. Welcome, everybody. My name is Doug Davis from IBM. I'm one of the co-chairs of the CloudEvents project, which is a CNCF project. And basically, CloudEvents is a project that was designed to help people manage events, basically around delivering events from one spot to another. Um, but before we actually start talking too much about the spec itself, let's talk a little bit about the history in terms of why CloudEvents was even created and what led us to even think about creating or working on it. So back in the middle of 2017, the CNCF Technical Oversight Committee wanted us to take a look at serverless technology. It was a relatively new technology at that point, and they were really just trying to figure out what, if anything, should the CNCF do about serverless. And so what they did is they started up a serverless working group whose main purpose in life was to do just that, produce a white paper that has sort of explained what is serverless, how does it relate to other technologies like functions as a service, platform as a service, or containers as a service, the other as a service offerings out there. State of the ecosystem, what's out there today from a proprietary perspective as well as open source perspective. Basically just trying to help you understand what is this space actually all about. And then finally a set of recommendations, if any, for what should the CNCF actually do about serverless, right? Should they ignore it? Should they get more involved, try to promote projects around it? And so that's basically what the serverless working group first did, is just sort of lay the groundwork for what's out there today. Well, one of the recommendations that they came back with, or we came back with, was that we were thinking about, is there a way that we can actually help the end users out in this community? Because there was a lot of really great, unique serverless solutions out there, but there really wasn't much in the way of interoperability to make life easier for people. So for example, one of the things a lot of people focus on around interoperability is, well, can I move my function or my serverless function from one platform to another easily? Well, not really, right? Unless they happen to share the same code base because it's open source. More often than not, they're kind of proprietary APIs around, say, the function signatures and stuff like that. And so there were things like that we sort of identified, but we realized some of those things that would really, really be great to do would also be really, really hard to do because they're going to be political and controversial. And we're not quite sure whether the industry overall was really ready to tackle that space. So we looked around and said, are there some what we call low-hanging fruit that we can actually tackle in the meantime, sort of building up to that? Get the community and the people producing products in the space comfortable with the idea of interoperability to help out the users. And we realized a lot of serverless is about event-driven workloads. So we thought, well, is there something in the eventing space that we can help people here or help out people with? And we talked about, the delivering of events from one spot to another, and in particular to your function, is something they all kind of do. And there may be some help we can attack or something a problem space we can attack there and help people out, okay? So let's talk about what is actually the pain that we sort of identified, right? So if you look at this picture here, what you see on the left-hand side is you got a whole bunch of these devices or event producers producing events. And eventually you want that event to go all the way to the right-hand side, right? To a data lake or to a function or something. But in the process of getting there, it can pass through many different componentry or middleware, and it may actually be transported over many different protocols, right? And the problem that we have here is while this kind of works today, the real pain is at every single one of these little blue boxes, it has to understand what the event is that's coming into the system, at least enough to know how to route it appropriately, right? And how to get that metadata out of the event to know, for example, well, is it supposed to go over this NATS, Kafka, or MQ thing to the event stream broker, or is it supposed to go down to that pub sub queue at the bottom, right? Those kind of decisions in terms of routing and stuff like that need to be made by middleware. But in order to make those decisions, they now have to understand the message itself. Now, they don't necessarily have to completely understand all the business logic of what's in there, but they have to at least understand the syntax of the message coming across so they know which bits of data they're interested in and where it is in those messages to be able to extract it to make those kind of decisions, right? And that's not easy, right? Because you got lots of different producers producing lots of different events in lots of different formats, and there's no commonality for the most part between them, right? It's a free-for-all. And so that means every one of these blue boxes potentially has to continually update the sort of its understanding of all the various messages that come into those systems. And then what if those syntaxes change over time, right? You got version 1, version 2, version 3 of these events coming through. All these blue boxes have to understand that. That's a lot of work and a lot of maintenance. Obviously, you can do it today, but that's a pretty big pain point for people, right? And so this is really the type of problem that we were trying to address, is how to help the event from point A, meaning the event producer, to point B, which is your function eventually, but help out that middleware to get it there, okay? So in 2017, or the end of 2017, CloudEvents was born. And as I said, it's an offshoot of the Serverless Working Group. And basically the goal here is to try to define common metadata for these events and where they appear in messages. Now, keep in mind, this is not yet another common event format that tries to force everybody into a single standard for what your event looks like. That's been done many times before with not a whole lot of success. And so we decided to take a different approach. We said, if you look at all the messages that are flowing around today, most of them actually have a lot of common data to them. So for example, a lot of them have some sort of type field that says, is this a create versus a delete type of message, right? They have a unique identifier, so you can do dedupe type stuff. They have information about where it came from, right? Source and subject, right? What produced the event and what is the event about, right? So for example, if it's a GitHub bucket, the subject may be the GitHub repo, right? Yeah. Then we have the time, right? When was this event actually created? Right? So you have all this common metadata that most events typically have already. So we took a step back and said, well, what if we take this common metadata that most events have and at least give them a well-defined name and a well-defined location in the message itself, so that the middleware doesn't have to guess or understand all of the messages that are coming through, rather they just have to know where to look for this particular metadata. And that's basically all the spec is, right? Common metadata, common location, and that's it. And it's not even all metadata. It's just enough metadata to help the routing get of your event from point A to point B, and that's it, okay? It's actually a really, really simple spec with very simple goals. It is not trying to change the entire world. It's just trying to reduce this one little pain point. So I like to tell people, this is not a sexy spec, but people are finding it incredibly useful. So it's one of those specs where I'm hoping it sort of weaves its way into people's a middleware, and it just sort of does its job. But it's not designed to be very flashy or make a lot of noise. It's just there to help people out. Okay. Now, I talked about how this metadata should appear in a common location, in different formats, and that's all true. But there's actually two different ways that it can appear in messages. The first is called binary, and that's actually my preferred way, because binary says you already have an event going from point A to point B. You already have an event format. You already have the structure of the message. You already know how it appears, say in HTTP or whatever transport you're using. All CloudEvents is going to do in that point is add extra metadata to your existing message, leveraging the existing extensions of that protocol. So let's take HTTP as an example. In that particular case, for a binary format for CloudEvent, all that really means is adding a couple of HTTP headers to the message. That means a couple of interesting things. One is you don't have to crack open the HTTP BY to look at the message, as a router anyway. And you as a middleware know exactly where to look for the message. And third, it doesn't have to break existing implementations, meaning a receiver that knows how to receive that message but knows nothing about CloudEvents will still work, because these attributes that appear as HTTP headers won't affect your message. HTTP allows you to have extra headers in there that the receiver can just ignore, and that's what it'll do in this case as well if it doesn't understand CloudEvents. But over time, if that piece of middleware does grow up and understand CloudEvents, now we can start leveraging those things and can stop having to understand what's in the body at that point in time. We can start using just the CloudEvents headers to do its routing. Okay. Now, the second format is called structured. This one says, if you don't have an existing event that's flowing around and you want some guidance to help you out there, fine, we'll help you out there. We'll actually give you a JSON format that you can use for your cloud event structure, or for your event structure if you really wanted to. And that's an option. And I'll show a little bit more about that on the next slide. But you have these two options for you. And as I said, my preferred approach is the binary one, because that basically means that existing message flows do not break at all. And they can still be used with your existing infrastructure without any changes at all until they want to actually support cloud events. So let's take another look at what this means through an example. So let's say you have a event being shown, or event flowing as shown on the left-hand side here, right? Very simple little HTTP message, nothing too exciting. But notice what happens now. Let's add a couple of cloud event headers to it, just 4 little headers. First one tells us the spec version. So this is the Cloud Event specification version that we adhere to, 1.0. It's the only version we have out there. CE type, so this is the Cloud Event type. This basically allows the receiver to look at this one field and say, okay, it's a new event from bigco.com. Now, obviously the phrase new event is could be a very popular phrase. So you may want to classify it based on, where it's coming from. And this allows you to say, it's not just any new event, it's Bigco's new event, right? So you give a little bit of scoping there, right? But typically, but you can obviously put whatever you want in there. It's completely up to you. It's just a string. Obviously, the more specific you get, the less chance of you having conflicts with other people. And the more specific you can be also allows for finer grained routing if you really wanted to. Okay, source, obviously this tells you where the event came from. So in this particular case, you could say that the bigco.com's repo component is the one that actually produced this event itself. And then we just have some unique identifier, as I said, mainly just so the receiver can do deduping and know if it's seen this event before. Very simple stuff. So again, nothing about this message has really changed in terms of a receiver that knows nothing about cloud events. But if you understand cloud events, now you can do routing based upon these 4 little headers, and that's it. Okay, that's the binary format. So let's take a look at the structured format. Now, the structured format, if you look at it, it actually has basically the exact same data. The only difference here is we define what goes inside the HTTP body, because in this particular case, the person who's using this said, I don't have a format that I'm already adhering to, so give me one that I can do. And just because they don't want to define one themselves, we said, okay, here's what it looked like in JSON. If for some reason you don't have your own format, or you don't want to pass these cloud event metadata as HTTP headers, because there are some people who don't want to process headers. They actually want it on the body, and that way we could take the entire payload and pass it on to the next component in one large chunk of JSON. And so we provide that as well. But if you look at it, it's basically the exact same data. The only change here is we define a data content type. So you can say what is the format of the data itself, which maps to the content type header from HTTP. And then the actual body of the message that would have appeared at HTTP body appears nested one level down under a data property. But you can see it's basically the exact same thing, right? So pick your poison, whichever one suits your use case, we got you covered basically. And you can tell the difference between the two, because if you look at HTTP content type header, on the binary, it's still the original application JSON. On the right-hand side for structured, it's application cloud events JSON. So that's how a receiver can know which format he has. And I believe we actually require both to be supported by implementers. That way you can actually, as a sender, send whichever one you want, okay? And that's basically it in a nutshell. It's not that hard, not that complicated, but it addresses that pain point of allowing routing to get the job done without having to understand the business logic of the event, or have to understand all the different flavors and syntaxes of the events coming in. Now, so who's actually using this? Well, for those of you who know about Knative, which is an open source functions as service offering, Knative actually took this to heart. And what they basically did is they made their eventing model under the covers completely leverage cloud events. Now, the eventing part of Knative basically is there to help people with the delivery events into their Knative environment, meaning where their function is hosted or their service is hosted. And what that basically means is they take the event as it comes into the system and normalize it into a cloud event. And at that point, everything that goes between the various componentry inside of the eventing infrastructure of Knative is passed around as an HTTP message wrappered as a cloud event. So as you look at those various components, if they need to do some special logic like routing and stuff, they know it's a cloud event and they can just use those headers, right? So you get that commonality. So let's look at that with a more concrete example. So you have an event producer who's setting an event into your cloud native environment. In the most simple case, what's going to happen is it's going to get received by some component called an adapter. And his purpose in life is really just, as I said, to take the event, convert it to a cloud event, and then send it on to the next component. In the most simple case, the next component is going to be your service itself. Nothing too exciting. And at that point, technically, cloud events may not provide a whole lot of value, at least from a middleware perspective. The service can still use it, right? The service will know it's a cloud event. It can use those headers if for some reason it needs to in its message processing. But from a middleware perspective, we don't have a whole lot of middleware, so there's not a whole lot of not a whole lot of benefit. That's fine. But what if you added something into the picture, like a broker, right? So let's say the broker is going to be doing fan out, right? So the event comes into the broker, and maybe there are a whole bunch of different services that are subscribed, meaning they define these triggers. And so you get this, again, you get this fan out of the event to multiple people. Well, in this particular case, triggers can have filters. And in Cloud Events, I'm sorry, in Knative, you can actually specify those filters basically by doing string matching on the Cloud Event attributes, right? So at this particular point, the broker does not need to know anything about the type of event coming in. It doesn't need to know whether it's coming from some, high-end enterprise system or GitHub versus GitLab or any other event producer out there. All the broker needs to know is, I'm getting a cloud event and I can do this filtering because the filtering is processing over the cloud event metadata, okay? And based upon whether it's true or false, it will then get passed on to the appropriate service. When the service is done, it can send back the reply to the broker, and then the broker can pass it on to the next component, again, as another cloud event. One of the other interesting componentry within cloud, inside Knative are things called parallels, and it's a different type of fan-out mechanism. Okay, in this particular case, an event comes into the parallel, and you can have a whole bunch of different conditions. And if any of those conditions are true, it's passed on to the appropriate sync. So it's a slightly different type of brokering type system or fan-out type system, but it's a very similar concept in the sense that as the events come through these things, they do filtering based upon the cloud event metadata. Okay, so again, this is, in my opinion, sort of the classic example of what Cloud Events was actually designed for, exactly this type of middleware processing. Okay. And so finally, just to wrap it up for the cloud event, from the Knative perspective, you can then mix and match these components to basically get an entire eventing workflow completely outside of your service. And it's all based on cloud events. So your event can actually go through this entire workflow thing, eventually reach your service, and you've done either filtering or whatever kind of workflow logic you want to have done on these events without ever having to really understand the business logic itself, unless you really wanted to, right? Which most cases, middleware, you don't. You just want to get it from point A to point B, and that's where the cloud event metadata helps you, okay? So let's talk about the core specification. As I said, it's really just about the metadata. So let's look at what that metadata actually is. I already talked about some of these. So you have the type, is it a create versus delete type of action, and who's create versus delete, right? So you get a little bit of a scoping around that action itself. The cloud event spec version is another attribute. Source and subject, combine those two to find where the event came from. In other words, who sent it, who's the event producer. And the subject is more about what the event is related to, right? So for example, in an object store, the subject might be the entity added to a bucket, right? So that's why you can do a little filtering to know, well, I only want to get events from one particular GitHub repo as an example, right? You might look at the subject for that type of filtering, okay? Unique ID, or I talked about that. Time, that one's easy. Or talked a little bit about data content type, right? That's the case where it's a structured type of thing, or a structured type of a cloud event. We had that field in there. And then we also have schema, right? A lot of people want to understand, based upon the schema of the event itself, meaning the schema of the business logic, do different processing, right? Is it version 1 or version 2 of this type of event? Send it to different processors. We allow for that to be in there. Now, it's important to understand that while we define all these things, only 4 of them are actually required, and those are the underlined ones, okay? And that's why I only showed you 4 in the previous example. The other ones are optional. They can appear there, but in order for the minimum to be a cloud event, you only need those 4. And the reason we kept it nice and small is because the other ones aren't necessarily part of every single event, but we also want to keep it really, really simple. Now, at the same time, you as an event producer or consumer, if you understand who your event producer is, you guys can extend this if you really wanted to. You can define extensions that can appear as other cloud event type attributes, and they have to appear basically in the exact same location, meaning in the HTTP case, in the binary format, as HTTP headers, prefixed with CE dash. That way people know exactly what CE headers or cloud event headers are in there, or metadata is in there, without having to necessarily understand everything in advance. Okay, and they could take the extensions, put them into a separate bucket, and that processor that understands extensions can go looking for them over there if they really wanted to. Okay, so that's the core specification. So other documentation that we have, obviously, as I talked about before, events could actually flow over many different protocols. So we support the 5 protocols you see on the screen here, HTTP, MQTT, AMQP, Kafka, and NATS. And basically, for I think almost all of these, we pretty much show you where the events are supposed to appear. The metadata is supposed to appear in binary format. In most cases, it's either in the extension attributes or headers type stuff, or how a message appears in the structured format, right? And what special rules might have to be there in terms of data types and stuff like that. As I said, I think all these support both binary and structured. I think only one of them, I think it might be NATS, only supports I think the structured mode. I'm not 100% sure, but most of them do support both. And then we also define what the event looks like for the structured mode in JSON and Avro, if you're interested in those two. Along with that, we also include a primer, which gives you some guidance in terms of how we expect cloud events to be used, but we also went one step further and tried to explain some of the rationale behind some of our decisions. Because in order to keep the spec really, really simple and as general purpose as possible, we had to really dumb things down. And some people look at us and kind of question why we made some of those decisions, because it may seem kind of limiting in terms of what we did. But if you read the primer, we'll be explaining why we did it. And hopefully you'll see why we made those decisions and why they were good decisions for the long term, right? It's not as complicated as it could be. For example, all the attributes are name value pairs. We don't allow nesting of properties for good reasons. Read the primer and you'll understand why we did that. It makes life a whole lot easier when you dumb things down. We also have what we call adapter specifications. This allows you to see how some events actually might get transformed into cloud events. So for example, for AWS S3 or GitHub and GitLab, we show which bits of metadata from the existing messages should get pulled out into the cloud event metadata. So that if you wanted to write an adapter that converts like an S3 event into a cloud event, if you follow our guidance there, you can do it in a very sort of common way, because the S3 folks and the GitHub and GitLab folks have looked at this and they basically say, yep, this looks right to us, even though they don't formally support cloud events themselves yet, okay? Documented extensions, we basically provide a spot here for people who want to extend cloud events with their own attributes to provide a home for those things. These extensions have no official standing whatsoever. They may change over time. They're not versioned with the spec. It's more like a wiki page more than anything else for the people to work together on some of these extensions. Now, if they become popular, maybe we'll add them to the specification at some point, but we wanted to sort of a testing ground for people to have fun with some new extensions. And then finally, because this is an open source project, we didn't want to put proprietary specifications or mapping to proprietary specifications or protocols into our repo itself. We thought that might look like people were trying to just promote their particular product. Instead, what we allow people to do is to say, okay, fine, if a particular proprietary protocol wants to do cloud events, that's fine. We're all in favor of that. But we don't want that specification that defines the mapping in our repo. What we'll do instead is put a pointer to that specification in our repo, and then they can host that specification themselves outside. So at least allow people to find those proprietary specs, but we didn't want it to look like we were endorsing one proprietary spec over another. So we sort of got out of that business. However, if you're working on a protocol or transport binding that is open source or standards based, then we're more than happy to include it as part of our repo if you want to work on that. Okay. Now, talked a lot about what's in there. Let's talk a little bit about what's not in there, because that's kind of interesting as well. So one thing we purposely avoided was security. A couple of reasons there. One is a lot of the transports already have security built in, so we didn't want to reinvent the wheel. And so that, from that perspective, that you can use what's out there today. But then you might be wondering, well, if you really have all these various hops, how do you get end-to-end security, right? Because point-to-point might be already done, but not end-to-end. Or how do you verify that no one's tweaked the message, along those paths by doing some sort of message signatures and stuff? All valid questions, and there isn't necessarily a great solution out there today. And we may actually tackle that at one point. However, we also acknowledge that trying to solve security problems like that is non-trivial and probably very, very controversial. So we wanted to actually produce the spec in our lifetime, right? We didn't want this thing to take years. So we said, okay, we'll leave that out for right now. We may come back to it later, but let's at least get the base spec out there first and see what kind of adoption we get. If it gets very, very popular and people are clamoring for some sort of security story, maybe we'll produce it then, okay? The other thing you won't find in there are sort of what we call transport level metadata. Things like, where is the event intended to go? Who sent it, or where should it be replied to? Not who sent it, but the reply to stuff. That's not in there at all for a couple of reasons. One is that should already be handled by the transport level stuff as well, or already. But also, these are events, okay? These are not messages. Now, events are typically one-way messages that can go to many different people. And when you start talking about replies, then you're getting into business semantics in terms of when replies are sent like that, and that has nothing to do with eventing from our perspective. You can layer that stuff on top of cloud events if you wanted to, but as part of a core cloud events, that's not what we're trying to tackle. So that's why we left it out. This is just events. We also have SDKs for a variety of different languages. The Go one in particular is used quite heavily in the Knative project. So pick your favorite language and we help you produce and receive cloud events. But obviously you don't have to use those if you don't want to. Hopefully your current message processing should just be able to pick up the extra metadata relatively easily. So in terms of status, in May 2018, we became a sandbox project, which just made us a little more real inside CNCF. But in October, we did two things. One, we became an incubator project, which gave us even more authority and more realness to us. But we also released version 1.0 of the spec. So now we feel like the spec is ready to go to be used in production. And at this point in time, we're basically just letting the dust settle and seeing how people feel about the spec as they start to use it. We've gotten lots of great feedback from people who are using it already. They love it. But we want to wait and before we actually tackle the next step for cloud events, like security and those things, to see what that adoption looks like first. Okay, and however, we're not just sitting back and doing nothing. The serverless working group is looking at what to work on next. In particular, we sat back and said, okay, great. You got these events flowing from point A to point B, but how does the consumer of these events know what events are actually being produced by those producers? Or how do I then subscribe to those events? Can we help out there? And we looked at it and said, sure, let's see if we can do that, right? Let's see if we can work on an event discovery spec so that a producer in a consistent and standardized way advertise what events are being generated for and for what protocols. And then can we standardize how people actually subscribe to those events? How do they specify filters, which event types they want, that kind of stuff. And that's a relatively new set of specs that we're working on. If you're interested in that space, please join us. It's obviously going to leverage cloud events going forward as an option because it's a nice fit for that, but it's still relatively new, so we'd love to get your feedback. And with that, I'm basically done. Here are some links for you if you're interested in it. Obviously, the first four are all about cloud events, the main site itself and the repos and stuff. If you're interested in the serverless working group, in particular, the white paper I talked about, there's a link in there. The working group has a sub working group that's working on workflow. If you're interested in eventing workflow type logic, take a look at that specification. It's still relatively new as well, but it's starting to get more and more traction, so you can take a look at that itself. I think they do support cloud events, but it's not a proper cloud event specification. It's just a general purpose workflow spec. We do have weekly phone calls, Thursdays at noon Eastern. If you're interested, anybody is free to join. And as I said, right now, our main focus is on the two new specifications, meaning subscription and delivery. But if there's other things related to cloud events, if you want to bring up or find issues you want to tackle in there, feel free to add it to the agenda. Okay. And with that, thank you very much for listening and hope everybody has a good day.